These special products will help you when you're doing multiplication. Now, you do not need to memorize these, but because like I said, the distributive property will always work, but they will save you a lot of time. Okay, they will save you a lot of time, but you don't need to memorize them. Just like the FOIL method, if you don't have it memorized, distributive property until you do have it memorized. So the first one is called a sum and difference of two terms, a sum and difference of two terms. So if you have two binomials that you're multiplying together and they have different signs, when you do that, it's just going to be a squared plus b squared. Okay, meaning this term, or these terms are the same here, these terms are the same here, is going to be a squared plus b squared. So like, for example, let me show you. Let's say you have 2x plus 3 times 2x minus 3. Okay, 2x plus 3 times 2x minus 3. If we follow this, they say square the first term minus the square of the second term. So a is 2x, right? So take 2x and square it, and then subtract that from, what's the second term? The second term is 3. So take 3 and square it. Ooh. Change the color because I didn't want it matching the purple. All right. If we follow this, they're saying that you don't have to do the distributive property. You don't have to do the FOIL. If you recognize that this, where you have the first two terms are the same, and then the last two terms are the same, and then you have a plus and a minus, it's a difference like that. So now this would be 4x squared minus 9. Okay, let's look at another one. X plus 3, x minus 3. If you follow this property, it says, okay, square these are the same terms. These are the same terms. So square the first one, take the x and square it, and subtract that from the 3 and square it. Looks like I picked 3 and 3, didn't I? So then this would be x squared minus 9. Okay, let's look at this one. 5 minus 7x. Oh, this is a good one. 5 plus 7x. Notice the variable has just been flipped, but don't let that confuse you. If you don't remember this, distributive property, right? Or FOIL, or learn this, right? And you just see it just saves you so much time because you don't have to do the math, or you don't have to do that much math. Let me rephrase that, right? You'll see that. So then 5 squared is 25, and 7 times 7 is 49. X times x is x squared. So the number and the variable are both squared. Cool beans? Easy? Okay, let's look at this one. This is the sum and difference of squares. Sum and difference of squares. Or sometimes they'll say squaring a binomial, because these are binomials. Okay, these are binomials. So a sum or difference of squares. So a plus b squared is the same thing as a squared plus 2 times ab plus b squared. And a minus b squared is the same as a squared minus 2ab plus b squared. Now, no confusion here. This means a plus b times a plus b. It's duplicated, okay, because of the squared. And then this one is a minus b times a minus b because of the squared, okay? But for the property, they combine this and they say it's equal to that, okay? Same thing here. This is equal to that. but I want you to know the duplication means it's just multiplied twice. And again, distributive property or FOIL, but if you can memorize that, it will save you some time. So let's look at an example. I'm talking about 2. Let's look at an example. So if you have x plus 2 squared, the property says square the first term, 2 times the first term and the second term, and then square the last term. Okay, because it's a plus. So then that means this is going to be x squared plus 2 times x times 2 plus 2 squared. Y'all see that? This matches this property here. Square the first term, take 2 times the first times the second term, and then square the last term. So then you end up with x squared plus 4x plus 4. This is a trinomial of degree 2. Easy? Good. Let's do one with the subtraction. Let's do one with the subtraction. Okay, I have 2x cubed. I said one with the subtraction. Okay, we'll do this one. I have one with the subtraction too. This has a 2 on the term, so that way we can still follow it. All right, so then the property says this is a plus, so we're using this one. Okay, and the property says square the first, 2 times the first and the second, plus the square of the third. So this is going to be 2x squared plus 2 times 2x times 3 plus 3 squared. So 2x squared, 2 times 2 is 4, x times x is x squared. So that's going to be 4x squared plus 2 times 2x times 3. 2 times 3 is 6. 2 times 3 is 6. 6 times 2 is going to be 12, so that is going to be 12x. Or you could have said 2 times the 2x is 4x, and then 4x times 3 would be 12, and then you have plus 9, because 3 times 3 is 9. This is a trinomial of degree 9. So far, so good. Make sure y'all can see the minus. There we go. So now let's do a minus one. X minus 3 squared. The minus says that the minus gives you a squared minus 2ab plus b squared. So if we just follow the property, it's going to be the first term squared minus 2 times the first term times the second term. See how I kept the minus with it? Keep the minus with that 3, okay? Oh, not like that. Sorry. The minus is here. Don't keep the minus with the 3. Ignore that. You know why? Let me show you why. You don't keep the minus with the 3 because the minus is right here. You see it? The minus, this is this minus here. So you don't need to pull it with the 3. Just follow the format. Follow the format. Sorry about that. And then plus the last term squared. Yeah, follow the format on these, because even when you do the FOIL method, it works out that way too. So follow the format. So that's x squared. That's minus 2 times x is 2x times 3. That's going to be a 6x, and then 3 squared is going to be 9. That is a trinomial of degree 2. Easy? Okay, good. This is a sum and difference of cubes, a sum of difference of cubes. You notice it's kind of similar to the squares, but these work with the squares. Okay, and so now we're doing the sum and difference of cubes. It's a little bigger. Now, this right here, this does mean a plus b times a plus b times a plus b. So if you don't have this memorized, you can still do this. You would just multiply these two first. You would end up with the trinomial and then multiply this last one to the trinomial. Okay, and then same thing for this. This does mean a minus b times a minus b times a minus b. That's exactly what that means. You would multiply these two first and you would end up with the trinomial, and then you would multiply that trinomial by this last binomial. Okay, so this one is a little harder to memorize, but if you can memorize it, it will save you time. But for the sake of our time, let's do some examples. I got two examples. So x plus 1 cubed. I'm going to follow this, okay? Follow it exactly out how it has it. It says I need to cube the first term and take 3 times the first term squared times the second term plus 3 times the first term, then times the second term squared, and then plus the second term cubed. And you're saying, well, Dr. B, what are you calling terms? This is the first term. That's the second term. Okay? First term cubed, 3 times the second term squared times the first term, 3 times the first term square the second term, and then the second term cubed. Y'all see that? So this is x cubed. This is 3 times 1 times x squared. 3 times x times 1 squared. And then 1 cubed is just 1. Easy? This is a polynomial of degree 3 because it has 4 terms. So we just call it a polynomial. Okay? 4 terms and we just call it a polynomial. Easy? I sure hope so. Okay, let's do one with the subtraction. And after this, we're going to do some, I call them oddball situations that you'll see. And I call it just for grins. We'll just do them just in case you see them. Okay, let's follow. We're following this, okay? Follow the property. Follow the property. So the first term cubed minus 3 times the first term squared times the, look, I almost did it. Follow the pattern, just times 3, because this subtraction here is the same as that subtraction there. So you don't pull the sign. Don't pull the sign. Don't pull sign because the property does it for you, okay? Now, if you were doing distributive property, absolutely pull the sign. But if you're following the property itself, then do it, okay? Plus 3 times the first term times the second term squared minus the second term cubed. x3, x3, yep, okay, cool beans. So that's x cubed minus 3 times 3 is 9 times x squared, 9x squared, plus 3 times x times 3 squared. So let me write this here. 3 squared, we know that's 9. Okay, so then you have 3 times x times 9, and we know that 9 times 3 is 27. Okay, so that gives us plus a 27 x, and then 3 cubed. That's 3 times 3 times 3, which we know 3 times 3 is 9, so that's 9 times 3, and that gives you 27. One of the things I want you to notice on all of our answers, notice the powers or the exponents go in descending order. That's the proper way to write these. So whatever software you're working in where you have to enter your answers and they say like a standard form, you want your variables to go in descending order. 4, 3, 2, 1, 3, 2, 1, 2, 1. They always go in descending order. Okay, that's the proper way to write these. Cool beans.